So basically, we're gonna now look at an example of dependent events. We have a bag that has 5 red balls and 7 blue balls. If I draw 2 balls simultaneously from the bag, if we were to show this information in a tree diagram, how it would look like. Let's take a look. So this is going to be the first case. I mean, sorry, this is the second draw. Now we're going to have to look at this problem before we jump onto it. Okay, cool. So first of all is that we are drawing 2 balls as 5 red. So we have 5 red balls and we have 7 blue balls. Altogether, we have about 12 balls, right? So we have 12 balls altogether. In the bag, if we draw 2 balls simultaneously, how would this look like? Right, so firstly is that we can start representing for ourselves what is, okay, anyway, we can take blue first, and then this is the case where we draw red. If we draw blue, the probability that we take a blue ball should be 7/12. And the probability that we take a red ball should be 5/12. Now, when we go to get a blue ball or to get another blue ball, there's something that's going to happen. The probability of getting a blue ball would now be 6 because you've taken out the first blue ball. So now the blue balls that you are left there are 6. It would be 6, but the overall balls that you now have, they are not 12 anymore. They are 11. If you go take a red ball, your probability now would still be 5/11. So the ball that you've removed was not blue, was not red rather, but it was blue. So the overall number of red balls is still 5. Same applies here. If you're gonna draw out a red ball, then you're looking at red ball, yes. So you've drawn out a red ball, so you're going to be looking at 4/11. And here, if you are drawing out a blue ball, you're going to be looking at 7/11. This is the probability that we have here, guys. The probability that we have at this point is probability of B given that B has happened. The probability that we have here is the probability of R given that B has happened. You know, and I'm not talking about, I'm just talking about this part, right? So if you were ever wondering what's happening with, I'm sorry, I'll have to go back to other class now. If you were ever wondering what was happening here when I was giving this formula, right? B, given that A has happened. That was the idea of that conditionality. I was referring to what was going on there, or what is going on here now, right? Now, this question, I doubt I want to solve it. I mean, we just said we must draw a tree diagram, but I want to tell you that the similar questions could be asked, right? I won't solve this problem. I kind of have solved it, but like the similar questions could be asked. They could, if you go back to the questions that we had just now, they could ask what is the probability of us drawing exactly one ball, you know, when we're drawing here. Then they can also, what is the probability that we draw at least 2 balls, what's the probability that we don't draw a red ball? So those questions can be asked again. And yeah, I'm not gonna do them here. You can play around with them. The way you approach them, there is nothing that will change on them. But it's a very nice way to sort of like see how dependent events play out. And then we have a homework. Did you guys all do homework?
But stuck here in the
Shana, Asset, did you do homework?
Yes,
I got
sir, but
stuck
I
at
also got
1B.
confused.
You got stuck where?
At 1B, so it's a similar question to this one though. Of the drawing of the cards.
Oh. Oh yeah, but they said that you draw the card and you replace it. So it's independent. Oh yeah, I mean, I know you guys said 1B, but yeah, would you now be able to do it?
I'm gonna try it, sir.
Wanna try it for, you guys can now do the homework, maybe until, okay, maybe I don't wanna do that. But please take care of that homework, guys. I'll move on to the next section. I'll now do Venn diagrams. So with these guys, this is just a way of representing, what's the word again? This is just a way of representing, wow, that's interesting. It's just a way of representing probabilities and sets and things like that. Maybe to start off with the Venn diagram, what I might say, is what I've said before, is that we can have a sample space like that. We can have things that are just belonging to the sample space, right? Like that. Just give me a second. Just give me a second. Yeah, so these guys, if this is A and this is B, these guys would be things that are either not in B and not in, when you're looking at something that's not in A and not in B, you'd be talking about these guys that have made stars here. But overall, you have a sample space, very clear what is in B, it's very clear what is in A. And also perhaps if you have something like that, that could be C. You have sessions where they intersect and things like that, right? But they can become, these ideas can become very involved. So I'll make an example. The example is that we have customers at Milky Lane. Milky Lane. So the customers at Milky Lane, we basically asked what flavors or what flavor of a milkshake they like. And here are the results. Okay, so we had 28 that like vanilla. Vanilla, which we can represent with a V. We had 25 that like lime. And we have 29 that like raspberry. And we had 5 that like all the favorite flavors. We had 7 that do not like any flavors. And then we had 11 that like lime and vanilla. So yes, we have 28 like vanilla, 25 like lime, 29 like raspberry, 5 like all flavors, 7 do not like any flavors, 11 like lime and vanilla, 8 like lime and raspberry, and 8 like vanilla and raspberry. I haven't heard Shana's voice today. Shana, are you okay?
Yes, I'm okay.
So we need to take this information, put it in some form that if we were to ask later on anything about these, we can make sense. And that guy would be a Venn diagram, right? So this guy over here would be our sample space. We will then have vanilla, for instance, and then we will have a lime, and then we would have raspberry like that. Okay, are we happy? So we're gonna start with things that are very easy to fill in here. 7 do not like any of the flavors. Go for that one. 7 do not like any of those flavors. So we're gonna put 7 there. 7 doesn't like any of those flavors. But, and then you come with the easiest ones. You'll see 7 doesn't like any of the flavors. We're gonna have to come to 5. maybe let me actually, this is where you start. You start with things like this, right? Where you won't have to do calculations to put in your diagram. So 7 do not like any, and we know that 5 likes all of them. So you see the number of people that like all of them, they kind of intersect at some point. Then you can come to the people that like 2 things. So for instance, you can come to the people that like, for instance, lime and raspberry. So the people that like lime and raspberry should be here. And ideally, there are how many of them? There are 11 of them. You would want to put 11 there, but you can't. There's already 5 people, and those people are included there already, right? So you need to say 5 minus, you need to say 11 minus 5. Lime and raspberry. I think I copied my thing. Oh yeah, no, it's not 11, it's 8. So you need to say 8 minus 5, and then that what you'll get there is 3. Right? Then you can go back to a section where it's combined
Wait.
again.
Sir,
Yes.
you said that 11 like what? Lime and vanilla.
Yes.
Okay.
So if you please, when you, after asking and you're done interacting, you can mute because there's a background noise. So we then have 11 that like vanilla and lime. So that 11 is here. So we know that altogether that must be 11. We already have 5 there. So we must say 11 minus 5, which is 11 minus 5 is 6. Sorry, it's 6. So we have 6 here. And then we have 8 that like vanilla and raspberry, but not lime. So they like vanilla and raspberry, but not lime. So we're just gonna, this one is nice. This is what would have happened before in others. In others, we had people, for instance, that like vanilla and lime. There were 11 of them, you see. So we had to say, sorry, let's take lime and raspberry, right? They were how many of them? There were 8 of them. We had to minus 5 because in that 5, people who like lime and raspberry were already included, right? So in this one is nice in the sense that it says, we want to look at the people who like vanilla and raspberry, but not lime. So we don't even look at other things, we just say it's 8, boom. So you can see you start by the people who like more things, because the more things intersects like 5, then you come to the ones that can like 2, and you come to the ones that like more. That more things, yes. Like, yeah, you come to the people who just like vanilla, for instance. So you know that the people that like vanilla should be 28. So here, this is going to be 28 minus 6 minus 5 minus 8. Because in this 8 and 5 and 6, people who like vanilla are included already, right? And that should give us 9. This should give us 9. And also, if you look at people who like lime, there is 25 people who like lime. 25 people who like lime. But again, we're going to have to say 25 minus 6 minus 5 minus 3, right? People who like lime, and that should give us 11. And also people who like raspberry were 29. So 29, So we're gonna have to say that minus that minus that minus that. So for raspberry, we are gonna get, you wanna ask?
So sorry, my connection just broke.
Oh.
And for no loser, I hope I'm not taking you guys back. The reason why we only saying 8, we do not include the people who like vanilla. So if
Where are you at? Are you talking about this?
I'm talking about,
Yeah, but people.
so we're only looking at the circle of R and V.
Yes, but not lime, which is really what the statement says.
Okay.
Okay, you can mute them. I get, when there is a noise, I do get disturbed myself. So yeah, anyway. So yes. So guys, can you please calculate what's gonna happen with the raspberry there, given that there is how many people who like raspberry? 29. Please calculate for me what's gonna be the value there.
$15, I think.
Just look again.
No, I'm lying. No, I'm lying.
So would it
Yes,
be 11?
just look again. How many people like 29? 29, where's my calculator?
It's 13, sir.
Yes, it is 13.
Oh yeah, I put 25 instead of 29.
So it's 29 minus 16, which gives you 13.
Yeah, it is 13. Okay, now you should technically be ready for all kinds of questions, right? From here. How are the questions? Questions are not different to what we've looked at. So I can now say, calculate the probability that a customer chosen at random number 1 likes vanilla. Number B, maybe we should leave some space there. Likes vanilla only. Number C, likes vanilla and lime. Number D, likes vanilla and lime, but not raspberry. So do you see, we can ask all these questions. Let me see if we can answer the first few. So for the one who likes vanilla, we're looking at the probability that the person likes vanilla. We don't care if they like other things, we just care about whether do they like vanilla. And that would be basically the number of vanilla over the number of the whole entire sample space. Now, the sample space, is basically when you add all these guys over here, that would make your sample space, right? If you add all of them, that would make your sample space. What did I do now? So the sample space here would be 62. So when you say number of vanilla over the sample space, the number of people liking vanilla are 9 plus 6 plus 5 plus 8. It's all the people that fall in the vanilla group over 62. And that should give you a probability of 28 over 62.
So I thought your question was for people who like vanilla only.
That's B.
And that's what I wrote.
Then we can now look at the people who like vanilla only. You guys can do that one. I'll just confirm if the answer is correct. It's also very nice to write it properly. Here, you're going to be looking at the probability that people like vanilla only. It's probably actually even nicer to do the following. Let me see if I can do it.
So will it be 1/7?
I'll confirm with you just now. Not really. 1/7. Oh, maybe that's a simplification. I'm not sure then. 9
Yeah.
over 62. No, it's not.
Oh wait, so wait. I put 63. It's 9/62, sorry.
Yes, that would be correct. So also it's just nice to look at these and look at, you know what it means with numbers now, and probably it's just, but also look at it as to what it means with the actual Venn diagram. How does the Venn diagram looks when you're just looking at people who like vanilla? Okay, did everyone get 9/62? Okay, that's nice. Just want to give you a perspective with what's going to happen, or probably how would this look like if we're considering a situation where people just like vanilla or is. So we're going to be looking at this guy over here. And then the second one, where we're looking at people who like vanilla only. Okay, this is going to switch off, and then we're going to have to join again. But yeah, just to represent the one that's going to be for vanilla only. Vanilla only would be this part. Ooh, I'm sorry, my pen is just been. Yes, it would be that part alone, like vanilla only. Okay, let's keep adding more questions. A, B, C, D, E. Let's say, what's my E saying? What was my D saying? Like vanilla, but not like, oh, okay, but not raspberry. Okay. I want, is it E? What does E say? Does not like vanilla. Look at who does not or do not like, or customers who does not like vanilla. I mean, not sure if I phrased that right. A, B, C, D, so I'll have F likes exactly. This is going to switch off. When it switch off, just join again. Exactly one flavor. And G likes exactly 2 flavors. That is very huge. The other one is likes at least 2 flavors. And I